He's right.
Y2. Isn't it like Y2 plus Y1?
Well,
That's how you get M. That's how you get M.
we're going to use the slope formula, but we are going to put it, the end result, in the slope-intercept form. And the first two examples that we did, guys, let me back up a little bit. The first example, remember, let's review from yesterday, okay? You guys gonna pay attention, right? In the back?
Oh, yeah.
Okay, awesome. The first example that we did yesterday, they gave us the graph of the line, they gave us the linear equation, they gave us the y-intercept, they gave us the slope, and all we had to do was graph it, right?
Mm-hmm. Yes.
The next example,
Uh-oh.
the next example, they gave us the graph.
Yeah.
And then all we had to do was find our y-intercept and the slope, and we could write the equation of the line. This is what we finished with yesterday, where they don't give us the equation of the line, and they don't give us the picture of the graph, what the line looks like. Technically, could you take something like this and graph it and find your slope and kind of do that? Yeah, but I'm telling you right now, there are homework questions. There's actually an example that we're going to do at the end of this lesson. There are going to be test questions where it's not going to be so easy to graph. What numbers are not easy to graph?
Negatives.
Negatives are easy.
Decimals.
Decimals, fractions, yeah. So we need another method, and that's why yesterday we used a different method in steps. Did anybody write down the steps of how we solved this yesterday? If you wrote down the steps, I want to hear those steps. We're going to write them again, and that's what's going to help us solve this triad. We're not going to do it together. We're going to recall the steps, and you guys are going to work on this. Jocelyn, give me the first one. What's step one?
Identify y-intercept. No. Plot y-intercept. No.
I think that might, those might be the steps from one of the other examples. Yes.
You put -1 and -5 and then 6 minus 4 and
Okay, good. Somebody tell me it without using specific numbers, just like step one. What are we looking for? We're going to find the, very good. Find the slope. If you didn't get this down yesterday, make sure you're getting it down now. Find the slope using what?
Y2 minus y1.
Yes, using the slope form, right? Slope form is slope equals y2 minus y1 over x2 minus x1. The difference of your y values over the difference of your x values, right? Now, are we going to do this right this second? No, we're just going over the steps. You can do this on your own. After you find your slope, what's the next step? Jacob.
I have a question. And like put in the values like
Yes,
so
good.
6 and then -4.
Oh, that would be the next step of doing this, but let's pretend that's all done. Okay. Let's pretend we have our slope.
Yeah.
What do we do next? I'll go ahead and write the slope-intercept form, y equals mx plus b. Once we have our slope, can we plug it in? Yeah. So we're going to plug in the slope. Once we have our slope, what's the other thing that we're looking for? The y-intercept. Very good. So we're looking for, what letter is that represented by? B. Remember when we talked yesterday about why is slope called m?
I sent you an
You
email
did.
right after
Yes,
school.
and here's candy.
I did it right as I got in the car.
I know, I got the email and I got one from Emily too. So here's the funny thing. Remember how I was like, I can't even remember why slope is represented by m. I'm like, there has to be a reason. I don't know why the y-intercept is represented by b, but there has to be a reason, right? Because maybe it's in Latin or something like that. What did we find? There's not really, nobody really knows.
There's not a reason, but it stands for like monster or something.
There are theories of like dating way back when people started writing these formulas. That one that I found was that somebody said it might be M for slope might be because of the word mountain, because like the slope of a mountain, if you think about that, that would make sense, right? So if you have trouble remembering what M represents, think of mountain, and then it will help you remember slope. But I'm telling you right now, I could not find anything that gave a reason why the y-intercept was represented by B. Okay. So we're gonna plug in our slope, and then how do we find the y-intercept if we're still missing all of these variables? We can plug in our slope, that will be plugged in, but we need to solve for B, so we need something to fill in for x and y. What do we use for
You use the slope formula that you did with that, and you add up and you subtract it, and that's your fraction.
That's your slope.
Yeah.
But if we need to find B,
Oh.
and we still have x and y as variables,
Don't you just like plug, like, subtract the y-intercepts?
not quite, yes?
We find out what y is.
No? Angelina?
You plug in one of your coordinate pairs into y.
Very good. You guys remember that from yesterday?
Honestly,
What
I
does
did
x
not
and
pick
y
that.
represent in this equation? It represents what? Yeah. It represents any what?
X-axis and y.
Well, it represents any point on that line. So if it gives you 2 points on that line, can you use one of them and fill them in?
Oh yeah.
Sure, you could use either one. You know which I like to use? The one with all positives. If you can choose the easier one, then choose the easier one, right? Don't make it harder for yourself. Okay, so we're gonna plug in our slope and one of the points. Once you have your slope plugged in and your x and y value plugged in from your points, can you solve for your y-intercept?
Yo.
Good. Now, with those steps written out for you, I would like you to solve this triad.
Yeah. I
Still
don't
don't get it.
I get it, but I forgot.
I did not get it yesterday.
Raise your hand if you want to try it on your own before I go over it. Okay, let's give them a few minutes and we'll go around and, are you good or do you want me to help?
I'm gonna attempt it.
I don't know how to put in like.
Just start with step 1. Get your slope.
For real.
For real.
I'm gonna try it, and if I don't do good, then I'm gonna.
How about if I'm without?
Just raise your hand if you want to get help started.
Yes.
I want to at least try it.
Okay. So the first thing you gotta do is, okay, so you wrote it over here. Write it nice and big over there, and then we can plug our values in. You're also gonna wanna write down your coordinate points.
It's like for the -1, would it just be -1 or would we make it minus -1?
Oh, I see what you're saying.
Yeah.
Let me pull over to you. Remember, kill the cockroach, change the sign. Okay.
Wait, is X the one on the left? I know, I'm like 95.
So- Here's another thing about points. It doesn't matter which one you call point 1 and point 2. It really doesn't, as long as you're consistent. So I'll just call my first one point 1, and my second one point 2. These are my x values and my y values. So if you want to, you can write down these points, and you can call them x1, y1, x2, y2.
So would it be,
That makes it easier to plug them into your formula.
so would it be X equals 6 minus 4?
Can you stop hitting the pencil?
Like for the
Well-
would it be X?
Hold on. Let me see your work, because I want to see about your positives and negatives.
Like would it be like N?
Plug it in.
Yeah, what is like N?
Oh, that one? Yeah.
And then
Use parentheses to protect, okay?
Is this right so far? I subtracted 6.
It is right, just reduce your fraction.
Oh.
Stop. Stop.
yeah.
Y2 goes first. Y.
Remember to use parentheses to protect your
Negative.
signs, yes.
I know what it is.
Okay. So when you plug in, you're rewriting your slope formula. blank minus blank over blank minus blank. Parentheses save lives. Well, they save math problems.
So I got it to this point.
That is not the correct slope. Let's see what we did there. I don't see parentheses.
Define this as
-1 is not. Because it needs projection. Kill the cockroach, change the sign. Kill the cockroach.
What are you guys?
No. This is cockroach. Change the sign. There you go. What's -1 here?
You just, here, I can explain the first part.
What's -1 plus -5?
Why did I not say that?
Do you think I just made up a new rule about subtracting integers?
Yes.
Do you think I would try to make more math more difficult? All I do is try to make it easier.
Who do you fork from?
All right, guys. Let's do step 1 together. We're having a little bit of trouble. If you can move on and you want to solve to the end, please move on. If you're having trouble, pay attention, okay? Keep your head outside of your sweatshirt, please. Can you keep your feet in, please? Thank you, so I don't do trippies. Let's fill in our values protected by parentheses. Everybody, I shouldn't hear any talking. I should just hear the sound of pencil and paper for the people who are working it out on their own, or you guys looking up in awe at this, okay? So we're gonna fill in our values. What's y2? 6. What's y1? 4. Yay, it's easy. I don't even have to kill the cockroach. I can just do 6 minus 4 is 2. I learned that in like 1st grade probably. Okay, so what's my x2?
Oh, wait, no. X2 is -1. And what's my x1? 5. Uh-oh, cockroach. Kill that cockroach, change that sign. Now I have -1 plus -5 is -6. What should I do with this fraction? Simplify.
Yeah, reduce, right? What would that be?
1 over -3.
1 over -3. If my numerator is positive and my denominator is negative, what does that mean about the entire fraction?
Negative.
It's a negative value. So when we write our slope, this isn't wrong. It's not a wrong value. It's just not the proper way to write a slope. If your slope is negative, you write -1 over 3. So we have found our slope. Slope equals -1 over 3. That's step 1.
Oh.
Take your beautiful slope, plug it in here. Wait, not on X, that's not good. Here, -1 over 3. What's step 2?
Make that a 4.
We plugged in the slope, check, and
Add in a point to
plug in one of the points. Then you can solve for B. Try that one.
How do you solve for B on that?
Did you plug in your point? Okay. Okay, well, first of all, you only plugged in the y value. You got to plug in the x value too.
That's not what we did yesterday.
It is.
Oh, sorry.
Oh, I'm still. Hi. Plug in your x value too. When we plug in one of our points, we have to plug in the x value and the y value. I don't need any glue. There's no glue.
No, he dropped it.
Oh, okay.
I'm putting it in my bag.
Miss Liz, so when I put
Sorry, I was going over here, then I'll come back to you, okay? Yeah. Yep, you can choose any point you want. I always go for my positives. Only one point, because you only have one x and one y. No. You use the whole coordinate pair. This is the whole point here. This is the whole point. 5, 4 is your whole point. This is your x value and this is your y value that need to get plugged in into your equation here.
Oh! Wait, no,
Wait, why are we saying 5 over 4?
No, it would just be 5, so the y would be 4, the x would be 5,
And then after that, you have to do the boom bam thing, and then you get B.
I don't know what the boom bam thing is, but.
I don't either. I
Okay.
didn't know what to do, so I just said boom bam thing.
Okay.
Fill in for my work.
Did anybody get it on their own? Oh, and also, just so you know, you're going to get a really yucky looking improper fraction as your y-intercept, and that's okay. Improper fractions are actually good. So you would have to multiply those. All right, everybody.
Do you multiply it, like, do you flip it, or just leave it like that?
We multiply fractions the same way every time. We multiply our nums, and then we multiply our denoms. Every time, that's how we multiply fractions.
We
Yeah.
would change the, so it would be 4 equals negative 3 times 5.
And negative 1 over 3
Okay, yeah.
times.
Times 5.
All right, I'm gonna need to add, oh, I'm sorry, you guys do your thing. Okay. Now times x would be what? 5. How do I want to write my 5?
5 over 1.
5 over 1, thank you, because we know it's going to be multiplied by a fraction. We're going to put the 5 in fraction form. Because negative 1 over 3 is being multiplied times x. When I fill in my number, the whole number 5 needs to change into fraction form. Because when we multiply nums and denoms. So I just automatically change it into fraction form. Every whole number is really easy to change into fraction form. Okay? Every whole number is really easy to change into fraction form. What do we do to change it into fraction form? Put it over 1. I know that's what you're going to say. Put it over 1. So I put my 5 over 1. No big deal, right? Don't try to do anything with it yet. I still have to add my b. Here we go. Look, one variable, everything else is filled in. Now we solve for b. What do we do first? Simplify. Yeah, simplify this. Yes, Vincent. Yes, go ahead. All right. We're going to simplify. We've got a 1 times 5. What's that?
Negative 5.
Okay.
Negative 5 over 3.
I'm.
5.
Oh, you all right? It's okay. It's okay.
My brain.
All right. They'll call back. All right. What's 1 times 5?
5.
I will make my fraction negative at the end. I'm just gonna say what's a negative and a positive.
5.
1 times 5 is 5.
Boom.
3 times 1 is
3.
3. A negative fraction times a positive fraction is negative. Good. So I'm gonna start writing it up here so I have more space to go down, okay? Are you with me? I still have my 4.
Yes, ma'am.
Equals. Then I have my simplified answer here. Negative 5 over 3 plus b, right?
Boom.
Now, here's the tricky part.
Alright, let's hear the tricky
Do
part.
you think you know what to do?
Yeah, I know.
Okay, I'm gonna say 2 things. I'm gonna say one thing. If you get the wrong answer, I'll be just as happy as if you give the right answer. Because the wrong answer is something that a lot of people are gonna do. So if it's wrong, don't worry. Yeah.
You subtract the negative 5 over 3 to 4.
You're so close, and it is very close to the right answer. Super close.
Oh wait, reciprocal.
That's the wrong answer I wanted to hear. Why do I want to hear the wrong answer? Because it's not the first time or the second or third time I've heard it. So I want to go over why we're not multiplying by the reciprocal. So thank you. Wrong answers are good. They help us learn what not to do. We usually, a lot of these equations that we've had so far this year, we're like, multiply by the reciprocal, right?
Yeah.
Why would you multiply by the reciprocal? What needs to be happening with the variable and that
They both
fraction?
need you to cancel out. If you want
What would cause you to multiply by the reciprocal? Yes.
You need to get B alone, right?
You have to be like divided by
Right. And we would do that because it's the opposite of yes. We would. Yeah, she got it right. All right, hold on. I'm just recalling that in the past we have had some things like, let's say it said negative 5/3 times b. Let's say it said that, okay? This is not what it says, don't write this down, okay?
Okay.
If this is what it said, if it said b times negative 5 over 3.
You would have to
Then we would multiply by the reciprocal.
because you want to get
Because
the
you do
variable
the-
by itself.
Right, and you want to do the opposite operation. We would be, this is multiplication, so we would divide by negative 5 over 3, which is the same thing as multiply by the reciprocal. That's the shortcut. Okay, but in this situation, this is not multiplication, it is addition. Okay, so you are on the right track when you said subtract because you see the addition sign, but technically we have a negative fraction, so what would we do to cancel it? Add it, very good.
Good.
Plus 5 over 3. A negative 5 over 3 plus a positive 5 over 3, what does that equal?
Nothing.
Well, it equals nothing, it equals 0. So now we just have b all by itself, but whatever we do to this side, and just like Emily said, she said to both sides, so we're gonna add 5 over 3 over here. Now I have a super ugly situation. I've got a whole number, adding a fraction. We're gonna have to go back to like 4th, 5th grade and get common denoms. I know, it's painful. It's just what we have to do with our lives right now. Again, I'm keeping my fractions improper because we want them to stay improper. I know when you were younger, it was all about changing those impropers to mixed numbers. It's not like that in algebra. We like things to stay improper, okay? Go ahead.
So you have to put the 4 into like a fraction, so like, and then figure
So
out
how would you put 4 into a fraction, a whole number?
you would do 4 of 1.
Good. And we are adding 5 over 3. So then what do I do, Grayson?
You have to change 4 of 1 to a common denominator.
Yep, which
So
would be?
It would be 3, but
Good.
then you have to multiply the 4 by 3, so it would be 12.
Good.
What in the what?
Yeah, 4 times 3 is 12.
Wait.
Every time you have to have a common denominator in order to add it. So whatever you do at the bottom, you must do the top order or vice
Oh, I
versa.
remember.
Boom, good job.
This was from,
How did I get 15?
I think why you guys are confused is like, it is a lesson you learned a few years ago. When you don't practice it every time, sometimes we forget the concept. But
We have to make that for a fraction.
I made it a fraction because to get common denominators, because if we're adding, remember, adding, you always need common denominators. 4 didn't have a denominator, so we put it over 1.
But we could make it 4 and 5/3.
True, but then we would have to simplify that into we would have to take the 5/3, make it a mixed number, add that to the 4, then change it back into improper fraction. Both ways, yeah, right? It's a lot of work. Both ways require a little bit of work. If you wanted to do it that way and then change it back into an improper fraction, that would be okay. I think this is a quicker way to do it, but both of them work. So what's 12 thirds plus 5 thirds? 17 thirds. 17 thirds equals
B.
B. What's B?
The y-intercept.
Y-intercept.
That means y equals negative 1/3 x plus 17 over 3.
That's it.
Boom, do it.
So remember in the beginning of this problem, you guys said, can I have graph paper? Did we need graph paper?
No.
Did it take a lot of work to get the answer?
No.
Yup. Is it possible to make a lot of silly mistakes along the way?
No.
Yup. It's just not easy.
Wait,
It's a lot of steps.
It's always
It's a lot.
Doesn't make
That's
sense.
it. But
Wait,
guess
so-
what?
wait,
There's
so-
more.
Wait, so the equation
What?
is 4 equals negative 1.
No. Once we use, all we're doing is writing the equation in slope-intercept form. Once we use our point, we just don't need it anymore.
Okay.
Because x and y are still supposed to represent any
Point
on
line.
the
Graph.
line.
Line.
Yep, okay. Now, we're gonna use exactly what we just did here
Okay, I'm ready for it now.
for the next thing, imaging, okay?
Easier than yesterday.
No.
Well, it's because we kind of practiced it again, so.
Yes, you were practicing.
Practice makes
Progress.
progress.
No, it makes perfect.
Nope, practice makes progress. We're not looking for perfect, we're looking for
And
progress.
that progress becomes
No.
I love coffee.
We had gift cards.
Of course, coffee is.
You don't like Starbucks gift card?
Oh.
Yeah.
Dunkin' Donuts, Kiwi Cup.
All right, who likes coffee? Me. Who's ever gotten a gift card to a coffee shop?
Me.
What was the starting value on your gift card?
$50.
Ooh, okay. That's generous.
50. 50.
1,
All
5,
right.
15.
Yes, I love coffee. I love
So
coffee.
here's the situation. Allie receives a gift card for her coffee, but
Ooh, I like coffee.
she doesn't give us the starting value.
Okay.
Okay? You know when somebody gives you a gift card,
I hate it. Someone just
you open
did
it
that
up, you're
to
like,
me.
yes,
And
and
I'm
it's like you have no idea how much it's for, so you're like hoping it's a big amount, but you're afraid it's you know,
Yeah.
it's a mind game. Okay. So we don't know what the starting value is, but we do have some information. Look. All right, girls. Check out this gift card. It has a graph on it. Can somebody tell me why we only show one quadrant of this coordinate?
Because you don't need the other one.
Hold on, I have a raised hand over here. I know, sometimes I let you guys call out. What is it? Yes, it's positive, positive. Very good. We don't need any of these other quadrants because we're not dealing with negative numbers. Once you run out of the money of your gift card, you throw it away. You can't keep buying more coffee. They're not going to say, okay, now you have a negative balance. That's called a credit card, and that's a whole other thing that we don't want to get into.
Hey, that's me.
Right? Yeah. So that's why our graph right here is just positive, positive. And let's see what we have going on here. Our x-axis, what does our x-axis represent here?
Medium.
Medium
Gift
cups
card.
of coffee. What is our y-axis?
Gift card balance.
Gift card balance. Okay, let's read a little bit more. She gets a gift card to the local coffee shop. Every time she goes to the shop, does she get something different every time?
No.
What does she get?
She gets a medium cup of
A
coffee.
medium coffee every time. So let's just say that there's no inflation during this time period that she has her gift card. So a medium cup of coffee is going to stay the same price, right? So when every time she goes to this coffee place, she spends the
Same amount.
same amount of money. Speaking of coffee, somebody needs a cup. All right.
Wake up.
Hey. That's my job.
Oh.
Okay. All right. So every time she goes to the coffee shop, she spends the same amount. The graph shows the gift card balance at 2 points. Doesn't show the starting balance. It shows 2 points on the
Graph.
line. On the graph, on the line. Do you agree that I could kind of draw a line here and maybe take a good guess at what the starting amount of the gift card was?
Yeah.
Like a really bad guess would be like, I think it started out as $80, right? It's like, obviously not. Or I think I started out as $12. No, that can't be. How could she start out with 12 and then have more than that, right?
Me.
What's your guess? 20. So, if we were to draw a line, maybe 24? That'd be a good guess, right?
Oh, yeah.
Yeah? Maybe 25, something like that. Okay. We're seeing a trend, right? We're seeing a trend because when I draw that line, I'm actually showing I'm showing the slope. Speaking of the slope, I asked this question backwards last class, but I'm going to ask it this way this class, because speaking of slope, what value represents the slope? I'll give you a hint. It's not an actual number. What value represents the slope?
19.7.
Oh, yes. We definitely could find our slope. But what value of this information represents the slope? A medium coffee? Very, very good. That was a hard question. The price of the medium coffee, because it's the same every time. So the rise and the run, now we're dealing with a positive or negative slope here.
Positive.
Negative.
No, negative.
Negative, because she's spending the money, so it's decreasing every time.
Oh, man.
So yes, it's decreasing by the same amount every time. So we have a perfectly smooth line. That is our slope. Very good. Okay, so the question asks, how can Allie determine the number of medium coffees she can buy with the gift card if she doesn't know the original value? No. So do you know the answer? Because I don't even know if I know it yet.
Normally, there's supposed to be a number on the back.
Right? And that would be so helpful, but let's just say there isn't. Okay, let's work through this because that question is really tricky. We're gonna find out the number of medium coffee she can buy, even though we don't have the original amount. But we do know 2 points on the line. In the problem that we just solved together, didn't we know 2 points on the line?
Mm-hmm.
What was the first thing we did?
Slope.
We found the slope. Remember? We're gonna find the slope. Can we use these 2 points, the
Yes.
x and y?
Yes.
Does it matter which one I call point 1 and point 2?
No.
No, it really doesn't. I'll just call this x1, y1,
What one?
and I'll call this x2, y2.
Wouldn't it have to be the same?
So this can be my first point, and this could be my second point, okay? Doesn't matter as long as you're consistent, yes.
Wouldn't x1 and x2 have to be on the same point?
So when I think you're thinking of the formula, m equals y2 minus y1, because we're finding the difference of our y
I
values.
just thought it was always like that, like x1, x2 always had to be on the same, on the same exact point, on the graph.
No, because the little baby ones right here, all they stand for is that they're the values for point 1,
Okay.
okay? And these baby 2s mean those values belong to point 2.
Okay.
Okay, those are what those baby numbers are for. Okay, so let's fill in our values here. Uh-oh, we've got decimal numbers, so I hope you guys are ready to get out your calculators, okay? Because I know I'm not doing that math in my head. Okay, let's fill in our values. Hey, guess what? Everything's positive. I don't need parentheses to protect. Okay? So what do we have? Can you guys fill in my values here?
Yeah. 14.4 is y2, 19.7 is y1, 4 is x2, and 2 is x1.
Very good. Break out those calculators. Tell me what you get for your numerator. 5.3?
No,
No,
wait.
negative 5.3.
Oh yeah, it's negative 5.3.
Yeah,
Thank you.
that's what I got.
And for the denominator, you don't need a calculator for that one. It's
4.
2, right? Now, remember before when I was like, leave your slope in improper form, right? Now I'm gonna. Yes, it is. Very good.
What?
Sure. But I still want you to pay attention, okay? And take all of my notes, even though you did get it all on your own. Very good. All right, so remember how I told you, go ahead and leave it improper, right? Well, I'm gonna change the rule a little bit just for this time, because when we're dealing with a real life situation, we're dealing with real money, right? And what did we say the slope represents? A medium cup of coffee. Does it mean how many ounces are in the cup of coffee?
Nope.
It means the
Price.
price. So shouldn't we just go ahead and divide our numerator by our denominator to get the price of the medium cup of coffee? Go ahead.
Negative 2.65.
Negative 2.65. So when somebody goes to the coffee shop and they look at the menu, does it say medium coffee price, negative 2.65?
No.
No, why is it a negative?
Because 5.3
That's
is
what we're
negative.
taking away.
Because we divided a negative by a positive.
That's because we're taking it away.
Very good, because we're starting with a gift card balance, and when she's buying it, it gets subtracted every time, taking away. So our slope is negative 2.65. I'm gonna write it all the way up here.
Whoa.
Y equals negative 2.65 times x plus b. Now what do we need to find?
B.
B. What can we use? Go ahead. Just don't
We
forget.
can use the numbers from the corner graph. I can't.
Yes,
use
we
my
can
alphabet.
use one of the points, right? Okay, so I'm gonna use this, what I just wrote up here, and I'm gonna try to find
2.
B by plugging in my y and my x value from one of the points. Does it matter which point?
No.
No,
I
and I
do.
don't really have a preference this time because they're they're both positive values. So, which one do you want to use?
2. It's the
This
easiest
one?
No, 2.
Lower numbers? Let's try that one, okay? So what's my y value?
4. Wait, no, sorry.
14.4.
14.4
4.
equals
4.
negative 2.65 times x, which is
4.
4, plus b. Welcome to the equations that we've been working on from the very beginning of the year, solving for one variable. I want you guys to, you can use your calculator. I want you to do that on your own and tell me what b equals silently by pointing to the number in your notebook. Please don't shout it out, okay? I know you got it.
And then, is that the answer after you get that?
We're so close to the answer. We're getting the y-intercept, and that's gonna help us get the answer. I promise, it's gonna be over so soon. Go ahead and solve that. You can use your calculators. Can you help or you good? You need a calculator. You guys don't have, oh, you guys are sharing?
Yeah.
Oh, I have it. Got it. Does anybody need a calculator?
There's a bunch in here.
Anyone?
I don't know my algebra.
Sit up, please.
Okay.
Yes. Give them just about 30 more seconds to get it. The is not by itself.
I know, but like,
Is it 4?
like.
Ooh, we don't shout out solutions. That ruins the surprise. And everybody's just,
I was guessing.
it's okay. It was wrong anyway, so.
Oh.
No, that's not right.
Right.
That is correct, very good.
I need help.
That is correct, very good. No.
No, wait, I'm gonna show the class.
Are you turning this into
No, she said.
All right, Uriah is going to demonstrate on the board how to solve this. For anybody who, I know some of you got it right, but anybody who's struggling,
Got Uriah.
and you can use a calculator for that first part if you want.
Alright, so first you do the opposite. So
Oh, okay. Yeah, you,
Wait, the way I did it was this.
okay. There's nothing wrong with that, it's just a little more complicated, I think you might confuse them. What we're gonna wanna do first, Uriah, look, is we're just gonna simplify this.
I'm just gonna.
Did I get it right?
This is the way I did it.
It's just the way.
So you can see this is subtracting by 2 going this way. So 4 minus 2 is 2. And this is subtracting by 5.3.
Hold on, Uriah. All we're trying to work on right now here is solving for b. This is the equation that we set up. Oh, okay. We already did that part. So can you just, okay, can you help me solve this part? Just this part. Can you do it? Okay. Okay.
Here, I'll do this like negative.
Oh, okay. Can I let her do it just because I love your participation, but I've called her so many times.
Just like.
Yes, I do that so many times because you're the and you don't pay attention. For B?
I caught my mistake, Miss Lay.
You did. Good job. That's right, Emily. Good job.
Just do that.
Wait.
You guys have to work on your teacher stance, where you stand out of the way as you're doing it. It's okay. It's hard. It takes
3.4?
Watch what I'm waiting.
Oh, I think I get what we're supposed to do.
That's it. B is 25. What does B represent? Which is also the starting value of the gift card, right?
Is that all we do?
That's what I did the
That's
first
not
time.
the answer though. It's just B. Okay, so we have B. Watch. 25 is B. Now, if 25 is the starting value of the gift card and every cup of coffee costs this, how do we find out the number of coffees she can buy with that gift card? I'll give you a hint. It's a simple operation. Is it addition, subtraction, multiplication,
You add.
division?
You divide.
You subtract.
You divide what?
25 by 2.
Two.
Negative 2.
Not -2.
Yeah,
That's you can do it there, and I did that in last class, but I don't have time. But yes, you just divide 25. Everybody punch in your calculator. 25 divided by the price of the coffee, not negative, because the 9.43 blah 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 blah. Right? So can she buy 9.43 cups of coffee? How many can she buy?
Negative 9.4.
No, not negative. Remember, the negative represented the gift card reducing?
She can buy 9.
She can buy 9 cups, so that's the answer. Before we finish, I need to introduce the next, oh wait, not this, hold on. I need to introduce the next lesson. It's really, really important, I do. But why does this keep happening?
Let's
To keep it blank. Okay,
Oh well.
no, I don't want that. Thank you. Okay. Okay, stay with me, you know my rule, if you pack up before I tell you, I will keep you after.
Why does it say swap?
I know, right? Your brother noticed the same thing. It says, guys, we're learning about point slop form today. Isn't that great?
Yay,
Point
swap.
slop form. It's actually point slope form, but we yet again have encountered another typo in this
The book should really.
okay?
We should just eat the book.
We should be just, well,
You
you
should
can't eat the
email the
You should
I
have
know.
said that.
Who's got time
That's
to-
a lot. It was
All right,
in
shh,
here.
I only have a few minutes, so let me go over something. This is going to make your brain hurt, and that's okay. If you don't understand what I do right now, it doesn't mean you won't understand this lesson. It's just, the theory behind this lesson. The idea, Melanie, book down. The idea, Jack, eyes open. The idea behind this lesson. So we know about slope-intercept form, right? We've got that drilled into our heads. Now we're gonna learn about something called point slope, not slop, point slope form. Point slope form looks like this. It's really weird looking. I like this one better, but we're gonna have to learn this too. Y minus y1 equals m times x minus x1. What the heck does that mean? So glad you asked. I'm going to explain it. Now, how can you write the equation of a line using any of the points on the line? Any of them. Now remember, x and y mean any of the points on the line. But we're going to write it in a way so that we would be able to use just one point on the line and the slope. And this is how you do it, okay? The first step, now this is not something you're gonna have to do. If you guys don't wanna take notes on this, I'm okay with that. This is more of the theory. We'll take notes on it tomorrow, but when we do an example. It's hard because they don't use actual numbers, they're using pretend numbers. So real quick, this is what it is. What is this? Tell me what that looks like.
Slope formula.
Slope formula. So we're gonna start with our slope formula. This is how we get from the slope formula to this crazy looking thing. We're just gonna rearrange some things. Now,
I think I get it.
we're gonna use the slope formula to find the slope of a specific point on the line. Do you agree that when we had a specific point on the line, we called it x1, y1, or x2, y2? Right? So if we're only dealing with one specific point, it's called x1, y1. It's the same thing as a point that might be +2, +3, but since we're not naming the point exactly, we're just doing the theory behind it, it's just x1, y1. It's just a specific point on that line. If we're going to use this, and we're going to use any point, do you agree that any point is just represented by x and y.
Yeah.
Okay? Because the 1 and the 2 represent specific points, the x and y just represent any point. So we're gonna substitute our y2 and x2 with just any point, the y and the x. So we're replacing y2 with y, we're replacing x2 with x. Do you have to know this? Not really. This is the theory behind it. We'll do the equations tomorrow. Then, from here, what we're gonna do is get rid of this denominator by multiplying it by its reciprocal. That cancels, because denominator, numerator, multiplication cancels. Do the same thing to the other side, and we get x minus x1 times m equals y minus y1. Don't worry about that, it's written down here. M times x minus x1 equals y minus y1. And look, this and this is the official way to write point slope form. Are these the exact same thing?
No.
What's the difference between them? They're just switched. Are we allowed to switch things?
No.
Are we allowed to switch things and still make them equal to each other?
Yes.
Yes. So we just kind of rearranged some things here and then wrote our point slope form. That is all I wanted to show you today. Tomorrow we will do lots of fun things with point slope form. Bye everybody.